So it's me. Welcome. And if you guys, already came on board, thank you. Thank you. This is our dynamic duo. It is my distinct pleasure to introduce you to Scott Henderson, Solutions Architect at Vcinity, and Brian Chipineri, Global Media Architect at Dell Technologies. Scott, Brian, thank you guys so much for joining us today. We are thrilled to have you. Awesome.
Thanks for having us.
Excellent. We're going to try to make this as interesting and memorable as possible. So that being said, that means that you two will need to do the talking. So let's get this party started. Scott, over to you.
Yeah, sure. Thanks, Lisa. I'm Scott. He's Brian. And let's go ahead and get started here. So just by quick way of introduction of Vcinity, we were founded as a way to solve a problem that the government had a couple decades ago, moving data across incredibly high latency links. There were some hard requirements for the project where the data had to be moved quickly across great distances with no modification and in a secure fashion. So we were able to accomplish that feat. And then a handful of years ago, we were given the opportunity to bring this capability into the commercial space. And in that time, we've become a Dell OEM engineered solutions partner, as well as a Dell Native Edge certified partner. So if we take our heritage of moving data across great distances securely and without modification, we look at how that manifests today across all industries. There's just a number of ways that you see this in some of your top initiatives. Certainly the one that we're going to focus on the most today is centralizing data that's being created out at the edge so you can make faster, better insights and better decisions against that data that's sprawled across the globe. As more and more cloud providers and other compute and storage services are launching next-gen capabilities, the ability to quickly get your data to that service is paramount. It allows you to take advantage of those capabilities without having to wait weeks or months or longer for your data to get to that platform. Certainly a hot topic now is Gen AI and machine learning. And something we like to say is that there's no AI without data. So whether you're building your own in-house AI platform and need to aggregate data to it, or leveraging a third party's AI service and need to push your data up to that service, data movement, quick data movement, efficient data movement, no matter the latency, is incredibly important because old data provides old insights. And then lastly, a lot of companies are thinking about what's next for their cloud strategy. Do they want to balance across multiple clouds? Do they want to move the significant amount of the workload back into the data center? And a strong mobility solution that allows for quick data transport between cloud providers, whether it's a public cloud or on-prem, is hugely important. So a lot of ways that this manifests. Now, in order to do all of this, we had to start from the ground up with a completely different approach to solving the problem of data mobility. So just at a high level, what we do is we build an incredibly efficient tunnel between two or more Vcinity endpoints. We'll get more into this in just a little bit, but just know that what happens inside this tunnel is what makes the whole thing work. And then we take this tunnel and we interface with existing IT services, in this case storage, using local protocols. So it's not a client-based service. It's not an everything out the door goes through the node. It's really a purpose-built solution for accelerating data from edge to core and edge to cloud. And the way that we built this effectively enables you to federate your cloud services, your edge services, your data center services, and more to get LAN performance at WAN scale. How does this play out in industry? We have a few customer cases we want to cover real quick. In the F1 space, a company came to us with a data mobility issue that was it was really threefold. One was really tiny files in the neighborhood of 600 megabytes of 1 kilobyte files. They were trying to move from the UK to the US so that they could operate on it. Another was their computational fluid dynamics data set that was large files, small files, and everything in between. And lastly was large ISO files that also had to get across the pond and back. And every hour they spent waiting for data to get back and forth was less time that they could spend building the next, the fastest race car. So we were able to show them that no matter the data set, we could significantly accelerate the movement of that data between source and target, to the point that the small data set that I moved, or the small file data set that I mentioned went from a 30-minute window to move that 600 megabytes down to 90 seconds. The numbers are staggering how fast this is for them. On the topic of ingesting data into a cloud, this is significant testing with AWS, but it just as well shows in other clouds, whether they're private or public. Moving data from one storage system to another, we tested all sorts of different storage formats, protocols, and depending on the data set, we showed up to 70x faster movement of that data across the country US, so 85 milliseconds. And the average was about 30x faster. So it's significantly faster than anything else that was available for that provider. In the defense space, I mentioned that our heritage is there, and we're still big in that arena. A modern jet fighter program had an issue where they needed to move initially just a couple of terabytes a day, or a couple terabyte data set from remote locations to the core. That quickly grew into 128 terabytes, and the time to move that data still remains sub 48 hours. So working with that program, we were able to meet and exceed the need there. And then lastly on this bit is we talk a lot about fast networks, but not all networks are super fast. So in a ship to shore scenario, this is with a cruise line, they needed to move large files across relatively low bandwidth networks, right? 20 megabits a second or so, but very high latency satellite networks. So up into the hundreds, 700 milliseconds of latency. And leveraging the Vcinity tunnel, they're able to get 32 to 36x efficiency improvement. So massive difference. And lastly, and this is what we're going to talk about on today's webinar, is video production data. So this was a customer that came to us through Dell and needed to have a better solution to their movement of data from the DIT Cart into their central data repository. So their data repo is in Northern California in the US, primary production in Southern California. So that's not too bad. It's about 10 milliseconds. But as they started looking at creating content on the East Coast of the US and in Europe and on a mountainside in New Zealand, they realized that the legacy solutions would not keep up with the requirements. So they were either hitting send and waiting days for the data to get back to Northern California, or pulling drives out of storage systems and shipping them. So two very inefficient ways to solve the data mobility issue. With Vcinity, and we'll show you the performance numbers here in a bit, we were able to show them that whether it was in state or the other side of the planet, they could achieve 85 to 90% network efficiency, no matter the latency, no matter the bandwidth here. So everything from 100 megabits a second up to 2.5 gigabits a second. So now as they're creating content in far off places, they know that it takes the same amount of time to move it from New Zealand to Northern California as it does to move it from Southern California to Northern California. So I don't know, Brian, I think I'll turn it over to you here to get into what this particular customer asked for in terms of physical and operational requirements.
Yeah, sure. Feel free to build out the slide. Yeah, I think when it comes to media entertainment workflows, there continue to be challenges moving large data sets. And what we're looking to solve for are a number of things. First of all, we want to parallelize the workflow as much as possible. So the more that we can optimize the workflow, we can get the content into the hands of the next creatives in the process, the faster we can execute on a project and get it into post-production, get content reviewed, and so on. The resolutions, the file sizes continue to grow, and moving data around the globe continues to be a challenge. So, how do we solve those issues? And then we have additional challenges when we're working on set, whether it's virtual production or whether it's actually on a location, right? We want to respect that we might need to have equipment that runs very quiet in a low decibel range, so it doesn't impact filming and audio, or that equipment may live in a virtual production in a small data center next to the set or the stage, if it is really noisy. But we like to keep it close to set or on set, and obviously this is talking about DIT technology, but also on set, you're typically going to have a technology stack of equipment with your switches and servers and storage and a full stack providing on-set technology services as well. So, this could be an extension of a complete stack. So, we're working in the day and age of camera to cloud workflows. And what that means is typically the cameras would have the capability embedded to make copies of the proxies and push those directly to the cloud. But behind that, we have the full resolution content that's been recorded, and we want to get the copy of those full resolution uncompressed files into the cloud as soon as possible as well. And so we have a number of challenges. So as we walk through, I have 6 performance tenets that we usually look at as we go through how do we optimize performance, right? And so we start off with, first, can we just optimize the stack for performance? We look at the networking, we look at the clients, the storage, and that end-to-end workflow, and at the application layer as well. How do we just optimize to make sure all of those individual components are working together efficiently? And we can do some tuning and adjusting across the stack. And typically we can get a few percent, maybe 10, 20% improvements on performance if everything's optimized and really tuned out as much as possible. But that's not always the case. And by the way, that does take time and effort, right? We have to put a lot of time and effort in to really look across all the components and make sure they're optimally running with each other, and everything is compatible. So that's the first thing we look at. The second thing we look at is, can we parallelize the pass, right? If we're pushing as much I/O as we can through one pipe, can we add more lanes? Can we add 2 or 3? And while that's great, you can say, well, now I can add 2 paths and I can double my performance. So this shouldn't be a big deal. But you're going, yeah, but that's like a leased line. That's going to cost me 15 or 20 grand a month, or whatever the cost is. And then the additional infrastructure cost to add more ports, more switching, and so on down the chain. So parallelizing the pass, well, that is a great option to improve performance. It's not always the right solution. And it also the cost benefits may outweigh leaning into that as the solve for this, right? And then we look at, well, let's just upgrade the pipes. Let's just make them faster. If they're 10 gig, let's go to 40 gig. If they're 40 gig, let's go to 100 gig, right? To support larger and larger resolutions and bigger data sets. So I think that goes hand in hand. That's number 3. That goes hand in hand with the next number 4 item in terms of my tenants for performance, which is just look at what is on the roadmap for next gen versions of the applications and of the hardware and the software. And as those become available, right, can we upgrade to that next generation of equipment and infrastructure that's just going to come out natively with faster speeds and feeds and connectivity to give us bigger gains? There's a cost associated there also, but honestly, we don't want to get too far behind in the equipment that we're using all around. We do want to stay current with our applications and our infrastructure to maintain competitiveness and feature functionality to stay current with the industry. The 5th tenet of performance that I look at is this content or these data sets compressible or dedupable? Can we get any kind of efficiency out of the performance in that regard? And that is definitely challenging when it comes to media workflows, because I mean, if you think about it, we might be working with EXR frames that are PIS compressed, and we might be working with lots of compressed content right off the camera. The content's already pre-compressed, so could we compress it more? And chances are, a lot of cases, the answer is no. There are algorithms that can be applied to raster images natively, so we can get some compression out of those and get some gains. And the concept here is, hey, if I can compress the data or dedupe the data and make it half the size, I can transfer it twice as fast, right? And so that's really the thought behind that. But it's finding that particular compression codec, for example, that's really going to be applicable across the board to lots of media formats that are being used. And that's a difficult thing to find as well. So, I really arrive at, if we've gone through all these tenets, what we're left with is, well, can we bring something in that's a little more specialized to support hardware and software acceleration or offload, right? And I think that's where Vcinity comes in and provides an accelerated tunnel end to end, so that we can just drive big data sets and transfer those as we need to, overcoming the challenges of latency, right? So, I think I've touched on all these. Let's keep on moving.
Sure.
What we've spent a lot of time doing is working and collaborating with customers to understand what are the challenges of on-set solutions. what type of infrastructure stack that we need to bring to bear. And so we have a really cool solution called the XR4000 or XR Edge solution. And it's a little server, it's a blade server that can literally fit in a backpack and can be toted around. And these have, up to 4 blades in them. And so, what we have looked at here is we'll run Vcinity on one of the blades and establish a tunnel over Ethernet to our remote site. And then we'll use one or more of the other blades to implement a full transfer solution like Cloud Soda is an example here, which could be running on the blades. And that's sort of doing our asset management. It knows what files are on the source side on set, and it's making sure those are getting transferred to the cloud. That's more of our transfer manager, our cloud transfer manager that's very efficient, and it's going to parallelize the IO and drive that at full scale across the stack. And then underlying that, we have some very fast storage in a small footprint, which is PowerScale, which would live on site with your DIT Cart or technology stack, and that can drive 100 gig speeds. So we're able to ingest content from multiple camera cards into the DIT Cart or technology stack onto the PowerScale storage, make that accessible right away, and then also in the background have transfers happening that are catching up with the proxies that the camera is sending directly to the cloud, so that we can get the raw content into the cloud as soon as possible. And so, if you imagine, how much time could this shave off of the workflows if we can do this? Like, can we shave a couple hours or even in total out of a project, a couple of days off of a project? Because we're starting to parallelize the workflow and get that content and get things reviewed and dailies checked out in full resolution that much faster. And what does that mean to our production budgets and our overall budgets if we multiply that across all the shows that we're working with throughout the year? So, we start to think of, this has business impacts, financial impacts. It's not just the technicals underpinning it, but, what is the real impact to production? How can we help deliver more value to production end to end? And, it comes down to like identifying these types of bottlenecks. And we realized, and our customers have told us that, hey, we're challenged getting these big data sets and moving these big data sets around. How do we solve that? And so that's where we invested a lot of time in partnership and collaboration to help bring forward solutions and reference architectures that can solve this specific problem for the media industry and help tackle that in partnership with you.
Yeah, that's great, Brian. Thank you. Yeah, so if we take everything Brian just said, we look at this stack of hardware and software and look at how transformative it was for this particular studio. Here's the kind of the rough architecture and workflow. So I'll walk you guys through this. So Cloud Soda, again, is the asset management integrity tool. So as the cards come out of the camera, in this case, they're uploaded through a laptop into the local Vcinity file system. At that point, there's still availability for on-set review, for color, and so forth. And then on the remote side of the storage location, there's a second instance of Cloud Soda that pulls the data from that Vcinity file system across through the tunnel and drops it into one or more storage targets. In their case, it was all S3, but it could just as well have been a traditional filer. So it's a very, very straightforward workflow. They get all of the goodies that they're used to with Cloud Soda. There's no new learning curve for the operators, and they can take advantage of that highly efficient tunnel between these two endpoints. So it's a very straightforward workflow, low impact in terms of a learning curve and high impact in terms of time to deliver. So let's look at those numbers. So the testing that we did there was 40 something tests, and basically we tested at a variety of latencies, 10 milliseconds, which again is roughly in state in California for them, out to 250 milliseconds round trip, which is the side of a mountain in New Zealand. And we tested it at several different bandwidth tiers. So what we're looking at now are the test results at 1 gigabit per second. So the data set was roughly 19 gigabytes, 30 files total. They're just sample videos from red.com. We're actually going to do a live demo here in just a bit using some of those same files. And you can see that at a gigabit, the time to complete difference from 10 milliseconds to 250 milliseconds was just 12 seconds. So 90%, 84% efficient, highly efficient tunnel, even as the latency goes from 10 milliseconds to 250 milliseconds. Now, the next screen we're going to do is we're going to zoom out on this data set a little bit on the testing results and see at all the different bandwidth tiers that we tested, we had that same consistent, predictable experience time to deliver data, where at 100 megabits a second, it was what's the amount, 8-second difference. At a gigabit, we already covered that, it was 12-second difference. At 2.5 gigabits, it was a 7-second difference. So now, no matter the latency, it's incredibly predictable performance because of the efficiency of the tunnel.
Mm.
So,
hey Scott, can I add
yeah.
a comment for you before
Please,
we jump
yeah.
in the live demo? So what's really important here is that we are able to deliver, Vicinity is able to deliver predictable performance. And that's always been somewhat of a challenge. It's like, well, how long is this data set going to take? Because I'm scheduling people in, down my pipeline to do work. And like, I don't want somebody sitting around for an hour or two with no material to work on, so how do I get these efficiencies into my production pipeline and optimize and automate and introduce that capability with, in a predictable nature. And so I think, that's part of what you're demonstrating here. In relation to media entertainment workflows. Yeah. Yeah.
The downstream impacts of an efficient workflow like this are more orders of magnitude. So we're gonna highlight this with a quick demo. I used this term earlier, and I just want to drive it home again. This LAN performance at WAN scale or a global LAN. So, and you'll see this during the demo. The performance across a high latency link is magnificent. So what you'll see here is we're going to copy a media data set from, call it the edge on the right side of the screen to the core on the left side of the screen. It's cross-country US, and we'll show you that we do get LAN performance. What's running the demo, because it's easy enough to set it up and tear it down, is a couple of AWS regions. The latency, depending on time of day, seems to be 60 to 70 milliseconds round trip. In each of these regions, and we're using the backbone. So in each of these VPCs, we have some storage. File system 1 on the right, file system 2 on the left. And we're going to move that data set from the right on this screen to the left on this screen. We're going to do that in a couple of different ways, so you can see head-to-head with and without Vicinity. So you'll see two computers on my screen in just a moment. You'll see a Windows VM with kind of a grayish wallpaper that it says traditional method at the top. And what this computer's done is it's mounted the NAS on the right, it's local NAS, as well as the remote NAS as mapped letter drives. Nothing revolutionary. It's what we've been doing for a very long time now. The second computer's got a bright, colorful wallpaper on the background of it. It says Vicinity method at the top. And we've got, on this computer, we've got an instance of our, we've got our data mover pulled up. That data mover is responsible for the mount to FS1 on the right. And there's it's the bookend to that Vicinity tunnels on the left side. And it has a mount for FS2. So all the plumbing is the same local area networks on both sides, the same wide area network in the middle. But the way that we're accessing the data, our data mover versus what we would normally do, is what is going to make our huge difference. Another data point to keep in mind is that the traditional method computer has full access to the backbone. I think that the upper limit is 5 gigabits a second. The Vicinity tunnel is shaped to 1.5 gigabits per second. So with that, I'm going to go ahead and stop my share just for a second so I can get those computers pulled up, make sure I'm still logged into them. Be off to the races. Let me just. All right, go back to the share. All right. Okay, so here's our two computers. Traditional method, again, storage mounted directly across. Vicinity method, storage mounted through the Vicinity nodes. So in our traditional method, we have, you might need to get kind of close to the screen to see this, but we have some of that same test data that we did with the studio. That's our FS1, and FS2 is our target. Again, that's in California. Our source is in Northern Virginia. So we've got two target folders, so you can see the difference. In the Vicinity target, there's nothing. In the traditional target, there's also nothing. So we're going to use this traditional method. We're going to click all three of our files all together. They're 11 point something, 11.5 gigabytes maybe. And we're going to just drag this across. Now this is very rudimentary. You may have a data movement solution that'll get you, who knows, maybe 30-40% improvement. But we're getting on a 5 gigabit network, we're getting 6-ish megabytes a second. So if we round it up, that's 50 megabits per second. And this is just cross country. Add more latency and this number drops even more. So this is why we click and wait, or this is why we ship drives. Now, with Vcinity, we're going to use our data mover. We're using the same file systems. This is still FS1. It's the same exact files. And on the right side, we've got FS2. So we're just going to move this into, you can see this is the Vcinity target. And we're going to watch it kick off down here. And just so we can get a nice, clean comparative view, we'll have our tunnel over so we can see both at the same time. So we'll see that leveraging the Vcinity tunnel, we're taking call it a 30-minute process and getting up to 1.4 gigabits a second. Remember, the tunnel is 1.5, so that's our top out point. So we are running sustained 1.5 gigabits per second. I should have started a timer on this, but typically it takes right about a minute, within 5 seconds of a minute, to run this across the country. So we'll let this go and finish out. May even be finished. Oh, finishing now. And all right, and it's done. So yeah, roughly a minute. This is going to be ramping down here as it finishes its measurements. And if we, this is still working, but what I do want to show you that if we go in, we go to the Vcinity target, we'll see we now have those 3 files in. So I don't do a whole lot of math, but taking a 30-minute process down to 1 minute is roughly a 30x improvement. And all we did was change the mount point to the data. It's the same source, same target, same data set, but using the Vcinity tunnel to get it there. So hopefully the demo here made sense. Hopefully it was beneficial. Certainly, if you want a follow-up demo, we're happy to get on that with you and dig into that further. If we want, we'll let that run and maybe we'll check back on it before we wrap up. But that number stays pretty consistent, 30 minutes, 28 minutes, and eventually it would finish. So let's go ahead and switch back to our content. So typically by this point, everybody just wants to know how it works. So I'll just assume that you've asked. So let's get into how this works. So at the core of this capability is the Vcinity tunnel itself. This tunnel is created and terminated on 2 or more Vcinity endpoints. This blue V circle represents a Vcinity node. It could be physical, could be virtual. Doesn't really matter for the purposes of explaining how it works. We create the incredibly high efficiency tunnel between the 2 Vcinity endpoints, and everything that happens inside that tunnel will work on any layer 2 or layer 3 network. So everything from a private wave circuit all the way up to a simple internet circuit and everything in between. Inside this tunnel, we do run, as part of our setup process, a tool that helps us to make sure that we do know what's going on between the Vcinity endpoints. There's a lot of goofy things that can happen on a wide area network, so we run that as an effort to make the full install process go faster. We discover things like packet loss and maximum transmission units and all this stuff, but the end result is that we can complete installs much more efficiently by leveraging this tool. You saw during the demo that we used the full 1.5 gig of the tunnel. Suppose you have a fast network or any network and don't want to allocate the entire thing to Vcinity. There is QoS. You can tune the max rate that you want to let Vcinity use across your network. And then lastly, encryption can be enabled for in-flight data. So when you're working on maybe less secure networks with sensitive data, as many of you do, you can ensure that that data remains secure and private while it's in flight. So if we expand this out to now look at how this integrates with existing storage services, it's the same tunnel in the middle. Nothing changes there. If you think of this Vcinity node, you split it down the middle. There's a WAN-facing personality that we just covered, and there's a LAN-facing personality, which is really just a server. So what we do is we mount 1 or more shares from your storage system. Here on the left side, we'll take NFS, SMB, S3 shares, doesn't matter to us. Mount that up underneath the server. Same thing on the right side, mount up NFS, SMB, or S3 shares underneath the tunnel. We do have and then each share is available to the other side, leveraging the Vcinity tunnel for acceleration in the middle. This is effectively terminating TCP services locally. So you still get all the goodness of what that was designed for, without the pain of in the middle what it wasn't designed for. So when it comes to moving data, certainly you can use legacy tools like we did with the customer that we were referencing. You have our data mover, which is accessible directly via the GUI, like you saw during the demo. Also, it's available via API. So if you have your own data movement service that you want to run API calls to move data using our tunnel, that's certainly an option. One reason you may want to do that is because within that, within our data mover, there's a small file packaging service. I mentioned that the Formula One team had those small sensor files, the 1 kilobyte files. We talked to an animation firm that's got a problem with moving small files across the wire to the point where they're shipping drives. So when it comes to moving small files, we can eliminate the pain of small file data mobility in a very simple, non-destructive, non-compressive way. We just package up small files by the set policy, move them across, and then unpackage them. So no compression, no deduplication requirements. It's just a simple process to optimize small file movement across the wave. So how this is brought to market, there's a number of deployment options. There's some animations on this. Okay, well, we can meet you at a couple gigabits a second with software all the way up through 4 to 5 gigabits a second available in the major cloud marketplaces. We've got, when we need to go beyond those bandwidth tiers, maybe get into 50 or 100 gigabits, maybe get some hub functionality. We can do hardware acceleration with one of our PCIe cards sitting inside of a Dell server. So you get looking at 50, 100 gigabits a second tunnel. We do have the two software tools that I described earlier as well. And then deploying this into the enterprise can look like point-to-point, like you saw during the demo and during the architecture review. It could look like hub and spoke, where you've got multiple edges connecting back to a single core. And then it could look like multi-hub and multi-spoke. So if you've got regional offices that each feed in content from regional production location, however you want to build this out, we can meet you where the requirement is. So to kind of maybe go back to where we started, is this need to move big, important data sets and how this manifests specifically in the M&E space. So on the topic of centralizing edge data, this is a way to ensure that no matter where your creative teams are in relation to the data that they need to work on, they can have instant access to those assets. On the topic of leveraging next-gen compute and storage services, maybe you want to take advantage of a rendering service in a particular cloud provider, or you want to flex into some available CPU resources that you have on-prem. You can quickly get those data sets where they need to be, so you can take advantage of whatever's most important from a compute process. On the topic of Gen AI, machine learning, more quickly feed data sets, get results, maximize creativity, maximize intelligence as you're producing content with an incredibly diverse range of inputs. And then lastly, with the cloud repatriation, cloud consolidation, hybrid cloud approach, get data where it's most needed, whether it's for regulatory compliance, whether it's for making the most out of the least amount of money, or getting maximum performance. So Brian laid out a number of challenges to data mobility in the M&E space, from compressible versus non-compressible, from how efficient the WAN is, especially as you get out to higher latency connections, and then what it looks like to deploy services on the edge. You don't want huge hardware stacks just to get a little bit of performance on the edge. So we've taken all those challenges, we've addressed them with our time here together, and delivered a solution that allows you to get immediate insight from data wherever it is for any part of the production workflow, pre-production, production, post-production, and even other than production workflows. So this wraps up my time and Brian's time. I don't know, Brian, if you had anything you wanted to add here before we move into questions.
Yeah, there's probably one thing. I think there's a distinction to be made where when you transfer the data to the cloud or the remote site, where does that data land? Does it land in an S3 bucket, or does it land in a file system? And so it may land in an S3 bucket, and then you might want to get access to that from remote sites and pull it back down to another site and put it into a file system to do some work on it. Or you might want to spin up a file system like PowerScale in AWS or PowerScale in Azure, and have a file system living in the cloud. So as that data is being replicated from onset into the cloud, it's landing on a file system, and you can connect editors in remotely to start actually doing some work on it right away. So, there's a distinction between, how you lay your workflow out, but all of these different variations are supported depending on, what your pipeline looks like and what you're looking to accomplish.
Yeah, that's perfect. Thanks, Brian.
Thanks.
Yeah. All right, Lisa, do we want to open up the Q&A?
We do. Now is the fun part. So I posted it in the chat, but for everyone, feel free to drop in your questions. We will be throwing Scott and Brian into the hot seat, so make sure they're difficult ones, or just interesting. But let me take a second and check those. Let's see. Okay, first coming through. This is actually related to, you mentioned what's nice about the solution is that we see that there's incredibly high performance regardless of latency, but also it's nice when implementing because there's not a lot of infrastructure changes or a lot of training changes. So how, kind of with that in mind, how would you think about the Vcinity solution in comparison to some of the technologies that are already on the market today, like a Signiant or a Spera?
Yeah, Brian, you want to take that one?
Yeah, well, I'll say this, with any solution that you're going to adopt, I'd say the most important thing is that it doesn't impact the workflow, or it doesn't, we don't have to go out and retrain the users and the creatives or the editors on something different, right? It should not impact the workflow. This technology should be seamless. It should run behind the scenes. It should just, give us the ability to move big data faster, but we shouldn't have to change anything about the workflow or the pipeline that we're not already doing. We don't want to have to go back in and retool our workflow to see these gains. And Scott, would you mind speaking to that from the Vcinity side? Is there any changes that would be needed from a workflow perspective by introducing Vcinity?
Yeah, there's a couple things. So, we talked about if you've got an existing tool, this particular customer, has Cloud Soda as their workflow management tool. It's a simple integration. For this particular customer, we just use the Vcinity presentation of the file systems to really integrate with zero friction. With a little bit of work, you can integrate via APIs and call the storage systems directly. So whether it's Cloud Soda like we did with this customer, or another workflow tool that works with files and folders, very straightforward integration. I would also add that when you compare the Vcinity solution at its core to other solutions at their core, as things move further to the right, whether it's latency moves to the right, bandwidth moves to the right, it's very difficult for the underlying protocols that those companies use to keep up with higher and higher latency and higher bandwidth, especially when you want to keep a minimal footprint out at the edge. So with Vcinity, we showed that we can get on a very small Dell XR server, we can run our stack that'll get you up to about 4 gigabits a second, which is very, very high performance for a software-only type deployment. So as latency increases and as bandwidth increases, you're going to find diminishing returns on a lot of those competitors that come to mind.
Yeah, that's great. And I think what's good there is you guys both have been saying, and this is something that you can stack on top of multiple technologies. So it's really something that's additive. You're not retraining artists. You're not messing with any of your existing infrastructure.
Mm-hmm.
Okay.
Yeah, programmatic API access is key, obviously, because we want to automate as much as possible.
Exactly. So talking a little bit about, Scott, you showed some really interesting graphs as well, which showed some of the varying latencies as you're moving a sample data set. Is there anything obviously in the film industry, a lot of these files are massive. Is there a cap, or how much data can be moved or copied in a day?
Yeah, that's a fantastic question. So back of the napkin math for estimating total data moved in a day is 10 terabytes per gigabit of bandwidth allocated to the vicinity tunnel. And that scales linearly up and down. So for 10 gig connections, it becomes 100 terabytes. For a 100 gig connection, it's a petabyte in 24 hours. And then as you go down the stack from a gigabit down to 100 megabits, it's a terabyte in 24 hours. So it's very consistent, predictable math, and as much bandwidth as you allocate to the vicinity tunnel will consume it at 85 to 95%.
Cool. I like it. I like it. Now to do a 180 and give you a little bit of whiplash. What about, we just talked about scale and large files. How do you do with small files? Because sometimes, we're just sending a couple small things over or multiple small images, whatever it may be.
Yeah. So we talked a little bit about that small file packaging, and it's so radically different in terms of workflow that it's typically the improvement by going from legacy workflows, just move in small files using whatever your best tool is, even with whatever engineering you can throw out on your site for parallelizing and so forth. With those tiny files, you're moving as much metadata as you are moving data. So your data mover can't get traction. If you think of it like a race car, it's like trying to get going on gravel. It's just constantly spinning because it's just tiny rocks that it's getting moving on. With Vcinity, kind of pave the road so that it's one large set of those tiny files, so that the race car can get traction and get moving down the road and keep that pipe full with maximum efficiency.
Nice, very nice. Okay. Other questions for seeing as I'm looking through, sorry. One was actually, so one of the biggest things we want to avoid in this industry is kind of leaking the next blockbuster. So great that we're transferring files. That opens you up to a lot of opportunity for threats, for losing content. What type of security do we think about with this solution?
Yeah, I'll talk to in-flight security, and maybe Brian, you want to jump in on data at rest security. So for data in flight, certainly we have tunnel encryption available with 256-bit AES encryption. With our hardware acceleration, we can also create multiple tunnels between endpoints, and then encrypt each tunnel individually. So we can, the tech word is inverse multiplex, but we can effectively create multiple tunnels across even the same logical physical link, and encrypt each tunnel individually. So if you are working on a very insecure network, very secure data, there's ways to go even beyond the typical AES 256 encryption for data in flight.
Yeah, that's important. I think end-to-end encryption is absolutely a requirement. I mean, no question about it. Additionally, I would say, especially for the storage, SED, self-encrypted drives are supported on PowerScale. So those are important because we're working in a facility that is in a virtual production site or a production site on set or remote, or DIT Cart or a technology stack that's on set. Remember, this equipment is not expected to be necessarily locked up in a data center somewhere with specific secure access to badge personnel. This equipment is out in the open, it's traveling. So how do you make sure somebody doesn't come up and rip drives out or steal something, or plug a USB in or try to do something? A bad actor could come in and try to steal some content, right? So PowerScale is also MPA compliant and CSVP compliant, so aligns with the media industry standards, along with TPN Plus, Trusted Partner Network. So I think that's an important distinction. In addition, PowerScale has auditing built in, so any type of I/O access that's happening can be tracked. You know exactly who is accessing every file at any given moment, or touching a file, editing a file, creating, deleting, all that. So it's the secure encryption end-to-end for the replication that's taking place. It's also, think about the physical steps that you need for physical security to make sure that if something happens to that piece of equipment, they can't access any data bits that are on it. And then also the logical layers in between of security that are additionally protecting that content at every step of every part of the workflow.
Yeah, that's great. One more thought on overall workflow security is that we talked about different other vendors in the marketplace for this type of workflow solution. And I mentioned it when I was talking earlier, but I'll mention it again, that the Vcinity solution is not an inline service and it's not doing any data modification. So it removes the potential security threat of having something in the data path that has to go and work on the data in order to do what it's going to do. So by taking out that requirement for accelerating the data, we take out a net new security threat.
Yeah, so it's like out of band, so to speak, which is good.
Yeah,
right? We don't
yeah,
want
it's like an
something
underlay now.
touching the data. Yeah,
yep.
That's cool.
Okay, awesome. Just rolling through with a couple more. One is there anything that we need to consider as sets change? So, I mean, it's a DIT cart. You may be moving from location to location to location. Is there anything you need to consider? Does this work kind of across continents or across distance?
Yeah, I can get into that, and then maybe we can talk about the Dell Native Edge aspect to this. So from a Vcinity perspective, it's very straightforward. If your public IP changes, the public IP that we see changes, then you would just need to update that on both ends and it gets married back up. It's very, very straightforward as the production is moving. Now, something to consider is as we look at technology stacks and we look at better, faster ways to deploy them and simpler ways to use them, we look at what Dell's coming out with the next generation of their native edge platform, and there's a partner in there that helps with that process as well. So I don't know. I think we had one other speaker that we might want to introduce.
Oh yes, someone who's been waiting backstage.
Yeah, special guest.
Woo!
Hey, everyone.
Hey, Mark.
Hey.
Thanks for hanging with us today.
So yeah, I'll tee it off here. So from the native edge perspective and what we can do from a full solution stack, the server stack, the XR 4000 and the XR platform that we're using here is fully native edge enabled device, which means that we bring a zero trust, zero touch onboarding deployment at scale to the platform, which allows to deploy Vcinity, which is completely certified. But not only that, we are working with other partners that provide that private 5G stack in there that can be deployed at scale, integrate with your own private software stacks that you need to deploy at scale in your own applications through orchestration layers. And that capability allows for the automation on native edge, and it's paramount. We look at Vcinity as a foundational component and how we can look and connect these disparate environments. So Scott, is that where you were?
Yeah, yep, exactly. And as it's kind of a building block approach to say, if you need data mobility acceleration, layer in the Vcinity solution. If you need storage, layer in the PowerScale solution, compute, and so forth. And if you need that cellular bonding, layer in that capability. So it's really a build to suit approach to deploying services out at the edge.
And I wanted to, I could just touch on security real quick. With layering in on the native edge platform and doing that, there's complete zero trust because of the FIDO connectivity. So, security is paramount in these environments. We don't want leaks of this material whatsoever. So you can lay that all the way from the TPM all the way up and control everything at scale.
Yeah, I think that's important because each production has its own stack, its own kit, if you will, that's being supported for the life of that show. And once that's complete, right, we want to repurpose that technology stack for the next show, for example. And so how can we do that in an efficient way, in a lights out way, very quickly with a hands-off approach, get access to that equipment stack, reconfigure it for the next show, for example, or for something that we may need for the current show. And so I think Native Edge delivers those types of capabilities to help with workflow efficiency, as well as all this embedded security that's provided.
Yeah, perfect. Thanks, Mark and Brian.
Cool. And as we're getting excited about all these things, this is something that is available now, coming soon.
Available now. Yeah. Yep. So we everything that we've shown here today, everything that we've talked about, is available today. We'll have some contact information at the end here. I'm sure it'll be sent out with the follow-up to the webinar as well. We'd be happy to engage with you on that and see what we can do to help you out.
Cool. Alrighty, and one additional question. This is mine and probably really lame, but as we've gone through a lot of content today, lots of demos, from each of you guys, kind of what's the too long, didn't read, one interesting thing to remember, or why is this solution noteworthy?
Yeah, I'll go first. From my perspective, it's the only solution in the marketplace that can offer the ability to have consistent performance no matter the latency, and that scales linearly as you add or subtract bandwidth. So it's consistent, predictable performance in a way that no other company brings to market.
That's good. I would say that what's really important today is efficiency, and efficiencies at scale, right? Being able to support remote working, being able to support connectivity everywhere is really important. We need to get the right people tied into the work. We need to embed efficiency in the workflows, right? And that means, you know, the optimizations, the automations, the API connectors, right? It all just works seamlessly to help us parallelize more of that workflow around the globe in more of a follow the sun manner. And so efficiency is really at the heart of this. And I think that's really critical to optimizing across the whole stack, right? I mean, this is not just a technical conversation. It becomes a business driver, a financial discussion. And if we're able to deliver more efficiency in the workflow, that means we can get more done. That's a huge benefit to every business.
Yeah, I think, Brian, you were mentioning before, hey, as we talk about efficiency, this is okay, I can say cut because I'm transferring data faster, I'm cutting a day off of my production process. And if I have how many productions a year times I'm saving a day gives me how much extra capacity or how many extra days for additional movies, new programs, whatever it may be, all with the same existing staff with the same existing infrastructure, which I think is really compelling.
Well, if you think about it, if I'm actually on location and I have 150 or 200 people, you know, on set at a location, you know, that who knows? It's $1 million a day, right? So if I'm getting this work done more efficiently, faster, I'm really delivering a key benefit back to the business in a lot of ways. And I'm helping drive, you know, transformation, leveraging this fantastic technology stack. So I think it's absolutely critical. And, you know, whenever we're doing designs, that's something that we're always keeping in mind.
Mm-hmm. Yeah, great. And I love that too. I know we mentioned this before that, hey, not only is there the efficiency piece, we just talked about how does that parlay into the kind of business outcomes, but also you're empowering your on-set teams, giving them the ability to review, and then the agility as your production schedule changes, as your locations changes. This is something that's very easy to port.
Yeah.
Okay, I'm trying to be mindful of time, or was at least attempting. So we're going to try to wrap things up here just so we can keep everybody on schedule, be mindful of time. So first off, I know we ran through a lot today. If we didn't get to your questions, please feel free to reach out to your Vcinity sales rep or your Dell sales rep. We're working together all the time. So happy to get you the right information. We'll also be, Scott dropped it in there already. Thank you. We will be sending out a recording of this session afterwards, so you'll be able to check that out. And then other than that, a big round of thank yous to everyone on the line. We know it is conference season, so thanks for hanging digitally with us. We appreciate it. To our speakers, this was great. Love the end conversations. It's always so much more interesting to say, hey, how does this actually work? Why is it valuable? So Scott, Brian, Mark as well, our special guest. Thank you guys so much for joining us, talking about a really exciting way to really modernize foundational and many workflows. So
yeah, thanks, Lisa.
Yeah.
Yeah, great seeing everybody today. Thank you.
Yes, yes, yes. So with that, I think that officially wraps it up. 2 minutes to spare. So we can all grab coffees before next call. But thank you again to everyone. We really appreciate it. And we know there's a million places you could have been today. So thanks for choosing to spend it with us. And with that, let's close. We will talk to y'all soon and send out a recording of this session. Thank
Thanks,
you.
everyone.
Thanks, everyone.
Bye.